Everyone. So today I am going to talk about how to use Langchain to build with LLMs, and it is a beginner's guide. So as we know that large language models are very powerful in general reasoning tools that are useful in actually a wide range of situations. But also working with LLMs presents challenges that are different from building traditional software. And this is what I am going to focus on today. So as we know that LLMs calls tend to be long-running and the stream generate output as it becomes available. And also instead of structured input, something like a JSON or with fixed parameters, they take unstructured natural language as input, and they are capable of understanding of that language. So also they are non-deterministic, so you may get different outputs even with the same inputs. Langchain is a popular framework for creating LLM applications, and it was built with these and other factors in mind and provide a wide range of integrations. One of these integrations and the most important ones, which are the chat models, like OpenAI, Anthropic, and Google, and also other open source models, of course. Today, what I am going to use is Anthropic Cloud large language models. Actually, it is available now for usage in Middle East, and I got the opportunity to got the API key and do like account and everything. So there are now different models, and the latest two are Snot and Ops. And according to this chatbot arena leaderboard, which was built upon this paper, and it is used like human preferences, which I actually like, other than other matrices for evaluation LMs. So we can see that Claude are the latest two ones. Ops and Snot are on the top five. And actually, this one is like the second one, and GPT-4 is still taking the lead. So today I want to build some experience and see how the reasoning is with this model. So what I am going to use is Snot model to build uh, this application for you and to show you how to use LangChain, I mean. So the first thing I need to do is to install some important packages like Langchain Core, Langchain Anthropic to initialize the chat model, and also of course Langchain. I already done that, and also I need API key, which I already got from this, and I put it as a secret key here, and I use this collab user data to be able to use it. Okay, so the first step, we need to get this model active for usage. And what I am going to do actually is to use something like this one, which is the chat model. And the chat model going to be the chat Anthropic that we have already imported. And we know now we have the model. As I told you, I am going to use Snot, and I will make the temperature for now is 0, so I will get the same answer as you running this app later. And we need also API key. API key is already here, so I'm going to change this, and here we go. So now we are ready to use this model, and of course, like the model parameter is like a string that matches one of the Anthropic supported models. Okay, so I am going to try something here. So like chat model dot invoke, and invoke we use it just to run this model. So tell me a question, or let's say a quiz question about machine learning. So this is what I am going to provide for the model, and I am waiting an answer now. And here is the output. We can see the output. Here's the quiz questions about machine learning. What is the main goal of supervised learning algorithm in machine learning? Okay, and also we can see some additional information. So like multiple choice question I got. So this is good. And now we can see that this output is called an AI message, as we can see here. This is because chat models use chat messages as input and output. So you were able to pass a simple string as input in the previous example because Langchain accepts actually these few forms of convenience shorthand that it automatically converts the proper format. So in this case, a single string is turned into an array with a single human message. Also, Langchain contains abstractions for pure text completion LLMs, which are a string input and a string output. Okay, so the chat tone variations have overtaken LLMs in popularity. For example, GPT-4 or Cloud 3 are both chat models. So to understand this is more, we can call the following for more explicit list of example of messages. I mean, so we have this dot messages imports messages, and here we go. We will do this one. Okay, but instead we will do the following. So we will do like this, and we will use human messages. Okay, and I will put the answer or the queue, and I will run. So as we can see, we get similar outputs. Next, we will talk about something called prompt templates. And actually, they are important and useful on their own. So, but it's often convenient to parameterize inputs so they don't repeat. So Langchain provides this prompt template. A simple example here. So we can import this. Okay, chat prompt template, and we can do something like this. Our prompt is going to be chat prompt template dot from here, no stick, from messages. Okay, and here we go. So what exactly it will contains the following. Okay, so we will have the system. Okay, and of course we also need system, and also we need what, the human. So we will take both messages and provide it to the model. So what will be the system message is like you are a quiz questions writer or whatever, and the human will ask something about tell me a quiz question about some topic. So I am going to define this topic. Nice. And here we go. We run this. I think I have something wrong with this one, so let's correct it. We need to do the following. Okay. There are maybe something with the spelling. Oh, sorry, I found my mistake now. So here we go. We need to define this, not this one. Okay. So here we go. Okay. So now we have this prompt template is ready, and what I am going to do is like to use this prompt dot invoke, and I will choose the topic now by doing the following. So topic is, for example, deep learning. Okay. So here is the results. The chat prompt value is messages, system messages, and what we have, and also the human message is we have like tell me quiz questions about deep learning. Okay, so let's go over it each step, and we will understand now. So we construct like a prompt template consisting of template like system message and a human message from messages. And we can think of system messages as meta instructions that are not part of the current conversation, but guide inputs. Okay, and the prompt template contains topic in the as I defined here. So this denotes a required parameters named topic. Okay, as I did here. And we can invoke the prompt template with a dictionary with a key named topic and a value of deep learning. So the result contains the formatted messages. Now we need to use this prompt template with our chat model. So now we will move to another concept called chaining. So as we have noticed that both the prompt template and the chat model implement the .invoke method, in Langchain, there are both instances of Runnable. So we can use Runnables into chains using this pipe, okay, and operator, where the .invoke, the next step with the output of the previous one. So here's example how to use it. So this is chain. We will take the prompt and then we'll take the chat model that we already defined. Okay. Now the resulting chain is itself runnable and automatically implements the .invoke as well as several other methods we will gonna see later. So this is the foundation of large language, or sorry, Langchain expression language, LCEL, and you can search about and find more. Now it's the time to invoke this. So let's invoke, and of course we need to define the topic as we have done here. So we'll take this and let's run. So now the chain returns like a quiz question about deep learning. Okay, so what type of neural network architecture is designed to process sequential data? Okay, I think we need only the question without other parameters that are contained in the AI messages. So Langchain has a component called output parser, which, as the name implies, is responsible for parsing the output of a model into a more accessible format. Okay, so sys-compose chains are also runnable. We can, like, again, use this pipe operator. So I am first going to import this. Okay, and now our chain is, I call it the string chain, the string, which is because the results or the output you're gonna see is like a string, and I am going to say that chain with the parser. Okay, so here we go, and I am going to run this, and now let's invoke this, but instead of the original chain, we are going to use this chain instead. And now we can see the results are like a string. Okay, so here we go. So this is great. Now, if you have noticed that once I run this example, I will wait some time until I got the response, and the response is shown as here immediately, the complete one. I mean the whole one. Okay, but now we are going to try a different thing, which is called streaming. Okay, and one of the biggest advantages actually that for these chains is the streaming experience, because all the runnables implement the stream method. So if you are working on like sync environments, including chains, this method dot stream, okay, this method will returns a generator that will yield output as soon as it is available, which allows us to get our output as quickly as possible. So let's try it. Here we go. I am going to do something like this for chunk, so we can see like how to get the multiple strings as outputs. Okay, so for chunk in this one, but now instead of saying that invoke, we are going to use stream instead, and please print chunk, and let's separate it so we can see better. Okay, let's separate it by this, separated by this. Okay, sorry, here we mean chunk, and here we go. So did you notice how now the answer is coming, and we can see how it works. So chains composed like string chains will start streaming as early as possible, which is in this case the chat model in the chain. Okay, now we are moving to like guide generation, but with context. I want you to know that LLMs are trained on large quantities of data and have some knowledge, let's say, about various topics. But still, it is common to pass the model private or more specific questions as context when answering to clean useful information or insights. We have heard about the term RAG or Retrieval Augmented Generation before, and this is the core principle behind it. So one of the simplest examples of this is to telling the LLM what is the current date is. Because LLMs are, we can say like snapshots of when they are trained, they cannot natively determine the current time. So I am going to provide this as an example, and we're going to see this. Now we have this one, and we're gonna, okay, so we need the, okay, let's define it again here, but this time without temperature, because we are going to ask about some question. Okay, so here we go. Okay, and let's ask about the current date. So here we go. And we will see that, unfortunately, I don't actually have the concept of the current date and time. Okay, so now let's see what happens if we give the model the current date as context. So from date time, import dates. Okay, so let's get the date of today. And we are going to provide like prompts for this, and we will create our chain as we have done before. So you know that the current date is current date. as we have done with topic. And the human will provide this question. For our chain, we will contain multiple things. First, the prompt, then we will have the chat model, and we will have, of course, the parser so we can get the answer. So I wrote it here wrongly. Okay, here we go. So now we can run this. We created our chain, and now time to invoke it. Once I invoke this, we will see that the current day that you provided is the day of today. So let's do another example. Now let's take a step further. Language models are trained on vast quantities of data, as I have said, but they don't know everything. Here, what happens if you directly ask the chat model a specific questions about, for example, let's take this example about local restaurants, asking about what was the old ship salon's total revenue in quarter one in 2023. And when I try to invoke this, of course, I am not going to give to receive any answers. Okay. And if we give the model more context, we can guide it to come up with a good answer. So let me copy the example directly and we can discuss it. So we will have the source having the name of the salon with the revenue numbers for different quarters, okay? And the system or the prompt template that I am making, the system message will be like, you are a helpful assistant, use the following context when responding to question for a human. And I created my RAG chain, okay? And I ask about the same question that we didn't get answer, okay? So the answer now is as the context I provided. So this is looks good, and I want you to note that the augmenting generation with additional text is very deep topic. So like in real world, this would likely take the form of longer financial document or portion of a document retrieved from some other data source. Actually, RAG is a powerful technique to answer questions over large quantities of information. And I am going to review some references in the YouTube video comments, so you can go later and check how to use like Langchain ChatModels generation for different data sources. But now we need to discuss something important called debugging. And this answers the last point, the third point I have started with, which is LLMs are not deterministic. So because of that, it becomes more and more important to see the internals of what's going on as your chains get more complex. So Langchain has something called set debug, okay, that will return more logs of chain internals. And here's an example of the date that we have used. So I am going to import from langchain.globals the set debug, and I am going to set it like true, and I will put my prompt and chain and everything, and I will see now the debugging. As you can see, we can see how the chain started, what are the inputs, and then we initiate like the LLM to get the answer, which is the chat Anthropic, the prompts, and now the generations that we have, and LLM outputs, including of course the input tokens, the output tokens, the model, the ID, and everything until we get the outputs. So this is great. And also there is a complete guide of debugging. I am going to leave the reference in the chat, or I mean in the comments of the YouTube video. So There is another way to represent, or another method for the debugging, called stream events. So we can use a stream events method to return this data. So this is useful if you want to use intermediate steps in your application logic, okay? So we can note that, let me just copy the code for you so you can understand what I am talking about. So here we go. So stream, chain a stream events, and we will have our like version. This is the first time we ask, for example, when we are using this stream events, and we're gonna to print like event in streams. So as you can see now, each event happening in the chain and in the retrieval are shown here with all the details. Okay, if you want more like better visualization of this debugging, we can use something called Langsmith. So Langsmith, we will see all the details about the things that I am running in the Colab, and including the latency, including the error rate, streaming, the total run count, the total tokens I am using, and even also the cost somewhere else. So it's easy to use this by providing like this code. So we need, once we sign up in Smith.Langchain, we can get our API key, and we can name our projects, and we can ask the questions. And once we ask these questions, it will goes here, and we will see all the runs happening like I am doing here. So when I run this, I get the answers in JSON format. You might run some evaluation matrices, you will see it in the feedback. Here are the metadata that we have used, and we can see more details about the chat model we are using and more information. So Langsmith will capture like all the internals at each step, giving you the results. So you can also tweak prompts and rerun model calls in a playground. Due to the non-deterministic nature of LLMs, you can also tweak prompts and rerun model calls in a playground, as well as like create datasets and do evaluation to your app to catch regressions. So that's all for today. Thank you, and see you later in another video.